Hello, this is Phil Thomas, New Era Systems. Here we have a beautiful thing. This arrived yesterday, brand new. It's an Anacom 50-watt EC transceiver. Don't see many transceivers anymore, but they still have an important part in today's satellite business. Let's see what we have here. Full set of cables. The yellow one is the AC power cable. The other two are M&C cables, because this is largely controlled by a computer, and you can see the Anacom Supervisor software on floppy disk. Who uses floppy disks anymore? They also offer a full set of manuals on this CD and another copy of the Supervisor program. But just look what it's rated for. Windows 98, 2000, NT and XP. I use XP, so hopefully I'll be able to still get this to work. This is Anacom's version of an LNA or LNB. They call it an LNC, and it is specific to Anacom transceivers. It also comes with a transmit reject filter, that long black thing. This is the C-band output waveguide flange. In this particular case, they've put a waveguide to N-type connector, because if you choose, you don't have to use twist flex or even rigid waveguide. With a 50 watt, you can quite easily run it on perhaps Heliax cable, something low loss, able to carry 50 watts of power. This is a rugged outdoor unit, and you can see by the shape of the fan that it's never been used. Over here we have the two IF connectors. They're both N-type. The TX IF, of course, comes from the modem, 70 megahertz modem, on the transmit side, and the RX IF goes back to the receive side on the modem. The two black connectors are for M&C to connect back to the computer for fine control of this transceiver. The red connector goes directly to the LNC. So now I've got quite a bit of work before I can fire it up. I've got to create an AC cable. The yellow cable that they provide doesn't have a connector on the end, so I'll just cable that up to either my 220 volt or 110 volt power supply and put everything else together so that we can test it. I'm going to use a CDM 600 modem simply because a customer inquired about a CDM 600 yesterday, so I pulled one off the shelf. I need to test that, and I can test this transceiver at the same time. So these are the two cables that I'm going to start with. The yellow is the AC power, and the grey one is going to be connected directly to my serial port on my computer. Together with Anacom's Supervisor software, I should be able to see all of the state and also the control options on this transceiver. Now I'm ready to begin the test of this Anacom 50-watt transceiver. I've made quite a few changes. It looks like a mess with all of these cables coming in and out, but they're all essential. The first thing to notice is that I have connected a Comtech CDM 600 70 megahertz modem. This is just a standard modem, nothing special about it. It certainly doesn't put out L-band, but that's what the transceiver is for. The transceiver takes the 70 megahertz input, it converts it in this case to C-band, so it doesn't upconvert, and then it goes to the power section of the transceiver, and it's going to output up to 50 watts. Now let's look at the components closely. Now the first item to look at is the LNC. This is the same, it does the same thing as an LNB or an LNA, it's just Anacom's version. Now what I've done here, I've added this converter at the end, because what I want to do, I want to input C-band downlink frequency, and the best way that I can do that is to connect this directly up to a frequency generator. This is what I'm going to use to generate the downlink C-band signal. The LNC is powered by the transceiver, and this cable provides the power for the LNC, but it also provides the converted downlink signal. So it's receiving a C-band signal, that's what I'm going to set up on the frequency generator. It's going to convert it down to 70 megahertz signal and then feed it back into the transceiver. The transceiver will then send it back to the modem. So it's a complete closed loop. I've removed that elegant little waveguide to N-type adapter, and in its place I've put a dummy load with a couple of monitor ports, because I want to monitor the output on the spectrum analyzer and also on the power meter, so that I can verify that this transceiver is transmitting at the right frequency, and I can also see the output level of the transceiver. Finally, I'm using my old Windows computer, and I'm going to connect via the Anacom special software. It's the M&C software. It will allow me to monitor all of the parameters of this transceiver and also make changes. So this is a very useful piece of software provided free of charge with all of these transceivers by Anacom. Now I'm going to start turning everything on. Be back in a couple of minutes to begin the test. First thing I'm going to do, I'm going to bring up the Anacom software. They call it their Supervisor. Cheat sheet telling me how to use it. Now I need to go over to connection, and I've already connected this transceiver directly to the serial port, so I'm going to say connect and register. So it's going to go looking for it now. It normally takes a few seconds to find it, and then we'll start to see some of the parameters coming from that transceiver. Now at the same time, you're looking at the Agilent power meter and at the spectrum analyzer. There is no output at the moment. That's because I don't have my modem set up in transmit mode. Okay, so now we're looking back at the Supervisor. We can see several things. The first thing down here, we can see that all the power supplies are well within the correct frequency range, so no problems there. On the transmit side, they set it up in channels, and they're fairly large increments, but that doesn't matter because we can use the modem itself to make the fine adjustments. And so at 70 megahertz, the output would be 6156. Now I'm going to go back to 6155 where I had it originally, and according to the Supervisor, the transmit status of the transceiver is turned on, which is fine. But you're not seeing anything on the spectrum analyzer, as I said a few minutes ago, because I haven't enabled the modem. So let's get around and do that now. Okay, the modem is on TXIF. The carrier is turned off. I'm going to press the down button, and now when I press the on, you should see a signal appearing on the spectrum analyzer and also on the power meter. I've got two ways of regulating the output of this transceiver. At the moment, you can see that it's running at about 24 watts, half its total output. And now looking back over at the Anacom Supervisor, you see there's a section here called TX gain. So what I'm going to do, I'm going to use this to adjust the power output. I'm going to sneak it up a little, and this is a gain, it's not an attenuation. And then I'm going to say save. And now we've gone up to 42 watts. And again, I'm going to go a little further, watching the power meter, and just a small increment brings me up to 50 watts. 50 watts is the nominal maximum of this transceiver. Now, one other thing, let's just look at the spectrum analyzer and do a peak search and see what it's reporting. It's reporting 6.1550125. That may be accurate, it may not, because you can see on the spectrum analyzer it says system alignments required. If I was really worried about the exact frequency of the output, I would have done a system alignment on the spectrum analyzer before I started this test. But in this particular case, it's more of a show and tell than it is a functional system test. So we've shown a couple of things here. We've shown that the output can be controlled on the Supervisor, and also on the Supervisor, I'm going to knock it back a little now. I don't like running these things at the maximum, so I'm taking it down to about 41 watts. Also on the Anacom Supervisor program, you can see the gain of on the receive side. Because although I haven't shown it yet, this modem is in fact receiving downlink signal. It's receiving a downlink signal from the LNC. It's a CW being generated by the signal generator. Now I'm going to look at the monitor port on this modem and make sure that we're seeing input from the receive side of the transceiver. So it goes under RX params, so receive parameters. It says that it's unlocked, and that's fine. It is unlocked, because to be locked it would require an exact signal in FEC modulation and so on. And we haven't got that, we're just generating a CW. Okay, so let's just summarize the test today of this 50 watt C-band transceiver. We do the major frequency controls using the Anacom Supervisor software. We do the fine frequency control using the modem. So even in today's world of bucks and L-band, transceivers can still be very useful, especially if you've got a legacy modem or legacy modulator and you don't want to go to the $5,000 to $10,000 upgrade price to go to an L-band modem or modulator. If you've got an old modem that will work, this is fine. A transceiver will also work. And don't forget, this is an outdoor rugged unit, so you don't have to worry about hauling long distance cables or waveguide carrying RF. All you have to do is to carry the lower frequency 70 megahertz transmit and receive over inexpensive cables, easy to make and cheap to buy. So that's it. This is my overview of an Anacom 50 watt extended C-band transceiver. I'm going to turn everything off now, get a little bit of quiet in the test section and move on to something else.